In this lesson, we're going to talk about lesson number 15, radiation. Now again, radiation is the high energy particles or rays that are emitted from a radioactive source. So we're going to talk about three different types of radiation. We're going to talk about how it causes a nuclei to change. And then we will discuss what the real world situations will be like. So our first type of radiation is going to be alpha radiation. So what is alpha radiation? It's a stream of alpha particles. Now you might remember alpha radiation or alpha particles from the Rutherford experiment when he tested if a chemical has a nuclei. Now what are these alpha particles? Alpha particles are large. Not only are they large, they're positive atoms, or positive particles, I mean. They're large, positively charged particles. They're bigger, they're more massive than the other two. They're massive particles. They're more massive than the other two types of particles we're going to talk about. Now, there's a way we use to represent these alpha radiation. But you actually usually use, because it has the same combination as a helium nuclei. Then because of that, we could use our standard atomic notation. So what does that look like? Well, what that looks like is you could write it as an alpha particle where it has a mass of 4 and it has 2 protons and it's also plus 2 charge, or we could write it as helium, the symbol of helium, with 4 mass, 2 protons, and plus 2 charge still. Now, due to the size of alpha particles, they are slow moving and cannot penetrate through many objects. Thus, they are not that energetic and they don't do as much damage. So how does that work when they decay? What happens during this alpha particles? Where does it come from? Well, an alpha particle comes from when we talk about alpha decay. Now what alpha decay is when a nucleus or nuclei emits alpha particle. And that's what we call alpha decay, because it's emitting an alpha particle, so it becomes to become more stable. Okay, now when it emits an alpha particle, because the nucleus is losing that, what's going to happen is that the atomic mass will decrease by 4. Atomic mass decreases by 4 because the alpha particle is going to leave the nuclei and it's taking away 4 mass with it. Likewise, the atomic number will actually decrease by 2 because it's taking 2 protons with it. So here's an example of this. Let's look at radium-226. So here's radium. Radium is a radioactive particle. It is number right here, 88. It's number 88. So radium-226 is radioactive. So how do we write this? Radium-226 is radioactive. Now it's going to undergo alpha decay, which means it spits out an alpha particle. What would the resulting nuclei become? Well, it lost 4 mass because this arrow, you think it was an equal sign. If it lost 4 mass, this new particle must have a mass of 222 because it lost 4 mass. It lost 2 protons, which means this new particle must have an atomic number of 86. What chemical is that? Chemical number 86 is radon. So it's going to turn into radon with a mass of 222 and atomic number of 86. And this is an example of what we call an alpha decay. Likewise, if we move to what beta radiation is, it's where you're going to be emitting beta particles. Emitting beta particles. Now, these beta particles are much smaller, and they actually have a special symbol. They are negative charge, and because of that, we can actually use the electron to represent, because it is represented by an electron. So because of that, the symbol we use is no longer alpha. The beta symbol ends up being a B with a tail, and it has no mass. But here's where it gets a bit tricky. What is the atomic number of an electron? It's actually -1. Now it's going to have a -1 charge as well, but the other way you can represent it is E with a 0, -1, -1 charge. Now why is it that it has a -1 atomic number? It will come into play because you're actually turning something, in this case you're going to turn a neutron into a proton and an electron. So we're going to see how that works. Now the last thing we're talking about here is that it is smaller, so it can go through most objects now. And it's also faster, so it does a bit more. It has a bit more energy. So what does beta decay look like? Well, in this case, you're going to have a neutron break apart into a proton, and the electron gets expelled. Well, because of this, what happens? Well, because you're forming a proton, you're turning a neutron to a proton, what happens is the atomic number goes up by 1. And we're going to show you why the symbol of beta decay has a -1 atomic number because of this. Not only that, but the atomic mass actually does not change because a neutron and a proton have similar mass, and thus the mass doesn't change. So let's show this with an example. So our example is, let's look at iodine 131. So iodine 131 is radioactive. It is right here. It has an atomic number of 53 in this case. So what's going to happen? Well, if it undergoes beta decay, it's going to spit out a beta particle. But what's going to happen? Well, because if this is an equal sign, then both sides have to equal. What is the new chemical's mass going to be? Is it going to be 52? Or is it going to be 54? Well, because that neutron turns into a proton, the atomic number actually will go up by 1. It's going to turn into 54. In this case, it turns into xenon. So it's going to turn into xenon, which has an atomic number of 54, but the mass remains unchanged. Now, why does it do that? It's because that neutron that sits in iodine decays. And it's going to spit out an electron, which is our beta particle, but it's also going to produce a proton, which is why our atomic number goes up by 1. And this is a lot more stable because of that. Our last type of radiation we're going to talk about is called gamma radiation. Okay, so gamma radiation is actually our highest energy radiation. But because of this, it does not change our element. Instead, what ends up happening, it's a redistribution of energy. It is a redistribution of energy. It's the highest energy. It does not change the element. And thus, because of that, it has no mass or charge. So, how does that work? Well, it has a symbol. The symbol for it looks like a Y with a tail. But it has no mass or energy change to it. So it's 0 and 0. And because of that, it is so much smaller because it's all energy. It can go through most objects except, for example, lead is one of them, or concrete, because they are still too dense for gamma radiation to go through. So what is gamma decay then? If it's just a redistribution of energy, it doesn't change the mass or charge, what does it do? Well, it releases energy in the form of gamma radiation, and it's going to just cause the nuclei to be more stable. So if I were to show this with, for example, nickel. Nickel 60 is a radioactive nuclei. Now how can I show this is radioactive? Well, I could put a little star at the top right corner to show that this is a high energy nickel. Once this undergoes gamma decay, it's going to spit out a gamma particle. And it's going to now, because it doesn't change nickel, it's still nickel 60, but it's no longer high energy. It no longer has that star. So this is how you show high energy gamma decay with an element. Now, can decays be combined? And the answer is yes, they can. So let's show an example with, for example, uranium. Uranium-238 is a radioactive element. Now it has atomic number of 92. Now let's have this uranium undergo alpha decay and gamma decay. Now because it undergoes gamma decay, it also means that it has a redistribution of energy. It needs a star. So let's write it out first of all as it undergoes gamma decay. If it undergoes gamma decay, it's going to release gamma particles. But the mass and atomic number does not change. And now this gamma particle is going to go out into space. But the uranium is still not fully stable yet. So it's going to undergo, in this case, alpha decay, which we know is an alpha particle getting released. Now, because of that, it's going to turn into, in this case, a mass of 234, atomic number of 90. It's going to turn into thorium. Thorium is going to be what it's going to turn into. So we can have decays happen we can have multiple decays happen to an element. That is possible. And that is actually what happens naturally a lot of times. So that's the end of our lesson. As always, make sure you stay safe and healthy, and I'll see you soon.